Welcome, this is lesson 12.2. We're going to look at specific sequences in series today, starting with arithmetic. Arithmetic sequence is one where you are adding or subtracting each time. We call that thing you are adding or subtracting the common difference. We're going to use the variable d to describe that one. So let's go ahead and take a look at what we've got here. First off, let's just see, is this arithmetic? So it has to stay consistent. It can't deviate from adding or subtracting the same thing each time. So we look at this and we've gone up 2. This has gone up 2, up 2, up 2. Yes, this is arithmetic. Yes. Okay, yes it is. Down here, we're subtracting. That's okay. The arithmetic you can subtract. That's a -5. But we just have to go one step further. You see that's a -6. No, not arithmetic. You have to stay consistent the whole time. That's what makes a arithmetic sequence so special. All right, let's go ahead and start writing the rules for these things. So you kind of know how in the last lesson how we wrote some rules. Now we're going to use a specific formula. Remember, a sub n is that kind of nth term idea. It's an equation. It's a rule that says if you tell me which term you want, I will spit you out the value of that term. And it's a pretty easy formula, one that you may have already started thinking about from the last lesson. You are going to take your first term, we're going to start out there. Your common difference is something that you have to identify, and then you are going to multiply it by the n minus 1, which, if you remember from the previous lesson, we have to have n minus 1 because that difference doesn't happen until really the second term. It really doesn't happen until the second term. And once you're done with this, you have to simplify. Simplify when done. Do not leave it in this form. This is how we start it, but we will write it out in the simplified form. So let's take a look at these two. Using that rule now, here's a for sure in arithmetic. We need to try to write the nth term. So we're trying to write a sub n. Okay, we're trying to write a sub n now. Okay, well, start with a sub 1. That's the first term. It's 2. You're going to add in, that d can be in the front, okay? You can put the common difference in the front or the back. It really doesn't matter. I noticed that the common difference is 7, so it's 7. And then we have to multiply by n minus 1. Just a simple distributive property here. We've got a sub n is equal to 2 plus 7n minus 7. We're going to take that -7 and combine it with the 2, 7n minus 5. Now, if you think about -5, that's really the 0th term, and you could go backwards to figure that out. We are also asked to find a sub 19, which just simply means plug in 19, okay, and see what we get. So a sub 19, 7 times 19 subtract 5 is 128. So the 19th term is 128. It works the same when you're subtracting. In this situation, we are subtracting 12. Subtracting 12 each time. So we say, all right, a sub n, first term is 57. Add it to a common difference of -12 and minus 1. This time when we distribute, we'll end up with a -12n. I tend to write the n term first, but then we'll have that -12n, but this will be a positive 12. So 57 plus 12 is 69. And we're trying to find the 19th term. With an explicit rule, this is really easy. We can just type this into the calculator. -12 times 19 plus 69 is -159. This checkpoint is where I'm going to quiz you. Once you're done with this video, or at this time now, you can pause it and do one on your own, but there is a quiz on Schoology that I want you to complete and type your answers in for this question. So you can do it now, or you can save it and go to the Schoology quiz at the end of the lesson. All right, let's try one a little bit more difficult. Now I've given you a sub 11 is 41. All right, I've given you just some random point along the sequence. I also have told you that d is 5. All we're going to do here is use our formula. A sub n is equal to a sub 1 plus common difference times n minus 1. And we're going to plug in everything we know. We're going to solve for our unknown. The most important thing for us to find right now is a sub 1. If we have that, we also have our common difference. We can write a rule. Here, n is 11, and my value is 41. So if I plug in, all right, a sub 11 is equal to a sub 1 plus d times 11 minus 1. Well, now I know d is 5, and I know that a sub 11 is 41. I can plug those values in and start solving for a sub 1. So here's a 41 is equal to a sub 1 plus 5 times 11 minus 1 is 10. So we're just using the rule, kind of going backwards in a way to find a sub 1. Subtract 50 from both sides, and we find out that our first term in this sequence is negative 9. Now that we have that, we can write our general rule. A sub n is equal to negative 9 plus our common difference of 5 times n minus 1. When we're trying to write the general rule, we don't need to substitute anything for n. We're just going to try to leave it. This would be a 5n minus 5. So a negative 9 and a negative 5 is going to make a negative 14. And there's your final answer. It's always a good idea to check. You can do 5 times 11 and then subtract 14, and you should get 41. Right? You can use this coordinate up here to kind of check your answer. This gets even more difficult here where you are just given simply 2 terms. So I like to think of it like this. If you've got a sub 6 here, and that is 7, and then you've got 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 is right here, and it's 87. How do we go from a sub 6 to a sub 22? Well, first off, 22 minus 6 tells me that there are 16 terms in between. Okay, there are 16 terms in between. And for each term, you are going to add d. That's the common difference. Add d. So how many times did we add d? Well, we did it 16 times. So I know that if I take 7 plus 16 common differences, where should I end up? Well, if I do it 16 times, 1, 2, 3, 4, all the way, I should get right there. I should end up at 87. All I have to do now to solve for d is subtract 7 and divide by 16. And our common difference is 5. 5 again. Now we have our common difference. We can use either of the terms. I'm going to use a sub 6. So we'll go back to our general formula. Now we got to find a sub 1 just like we did on the previous example. So I'll go to my general formula. I'm going to use n equals 6. So when n equals 6, if this is a 6 right there, then I know that this term becomes 7 equals a sub 1 plus my common difference is 5. And if this becomes 6 right there, 6 minus 1 is 5. So it's 25. Subtract 25 from both sides. 7 minus 25 is going to let us know that a sub 1 is negative 18. And now we can wrap it all together back in the original formula. A sub n equals a sub 1 plus d times n minus 1. And if we're going to write the general rule, a sub n is equal to a sub 1 is negative 18 plus common difference is 5 times n minus 1. And when you multiply this out, a sub n equals 5n minus 23. And there you have the simplified version. So a lot more work when you're trying to find the nth rule. Remember the 2 things you need, a sub 1 and the common difference. So you got to work to find those. When you're given it, like we were in the early examples, it's just a matter of plugging it in. But when you're not, you do have to do some work to try and find those questions. There's a quiz again, a question following this checkpoint where I want you to try. You're given a sub 5 and a sub 20. I want you to first find the common difference, then find a sub 1, and then go ahead and put it all together in the equation. We've written the rules, now we're going to find the sum of those things. So if we're going to add them together, the formula that you need to write down and start to become familiar with looks like this. Essentially, you are taking the average of the first term and the last term. That's what this means right here. A sub 1 is the first term. A sub n, whatever you're supposed to do, it's the last term. And basically, when you add things together, you've got a really big number and you got a really small number right at the ends. And you can take the average of all of the numbers, and that will tell you the sum of all of them. So very simply, if we sum up like 1 through 12, or let's do 1 through 11. Okay, we're going to sum 1 through 11. We've got 1 plus 2 plus 3, 4, 5, 6, 7, 8, 9, 10, 11. All with addition in between them. If you take the first and the last term and add them together, you'll begin to notice a pattern. 1 plus 11 is 12. Okay? 2 plus 10 is 12. 3 plus 9, 4 plus 8, 5 plus 7, and then half of... All right, so we will try and find the sum here using this formula. Here we've got a summation notation. We're summing from the first term up until the 15th term. So we're summing a sub 1 all the way to a sub 15. And we just need to find those values. So we can plug in 1 and plug in 15, and that's how we'll find them. If you plug in 1, or I equals 1, we would have 9 plus 3, which is 12. And then a sub 15 is 9 plus 3 times 15, that's 54. So from here we can just use the formula. We're trying to find the sum of the first 15 terms. We're going to sum up 15 of them. N is 15. My first term is 12. My last term is 54. And I need to find the average of that right in the middle. So S sub 15. When we simplify this, 12 plus 54 divided by 2. If we divide by 2 is 33, so this is 15 times 33, which totals up to 495. So the sum of the first 15 terms, 495. Here's one more checkpoint. I'd like you to try that same thing. We're summing from the first term up until the 18th term. So go ahead and plug those in and see if you can solve for the sum on your own. I've got one more additional practice problem that we may come back to later, but for now, this is it for 12.2.